Hello children, welcome back to physics class. In today's class, let us discuss in detail regarding the methods of magnetization, demagnetization and the types of magnets. Okay, so let us discuss one after the other in detail. So first of all, methods of magnetization. Any magnetic material can be magnetized with the help of few methods. First one is single touch method. So what is a single touch method, children? So in order to, suppose if you were given a bar, iron bar or steel bar, let us only consider steel bar. Okay. So whenever you are initially a steel bar is being given, then take a bar magnet. So first of all, consider only a steel bar, okay, and also a bar magnet. What is a bar magnet? Which have two poles, north pole as well as south pole. So holding the bar magnet from one end, suppose that this interfaces a north pole, this is a south pole, continuously. So start from here, like this, like this, like this. Drag this bar magnet towards the other side. Again lift it up, again hold it, again bring it like this. Again remove it, again hold this and move on continuously. If you only one particular direction. So you are only continuously rubbing the steel bar with the help of a north pole in one particular direction. So using one single magnet. So this type of magnetization. So then later on, as time passes on, if you continue this process for a while, then we observe that this steel bar gets magnetized after some time. As you are rubbing this with north pole and ending it here, so wherever it starts, this is starting from this pole. So wherever the north pole is starting, okay, there north pole is formed and at the other end the opposite pole is being formed. So that is south pole, and this type of method is called as a single touch method. Single touch method. Okay, so this method is called as a single touch method. Now we shall also understand another methods, that is double touch method. So again double touch methods is again of two types. Okay. So one is divided double touch method and the other is simply double touch method. So what is divided double touch method? Means again consider that steel bar. So on this steel bar, now you have to consider double touch means two magnets you have to consider. So keep one magnet here, the other magnet here, such that at the middle, for one magnet north pole must be facing and the other magnet south pole must be facing. So you have to rub. So from middle of that north pole is taken in one direction, from the other side south pole is being rubbed with the other direction. Continuously you have to rub the steel bar in one particular direction. So like this, like this, like this. Okay. So as long as it is being repeated in the process, after a while, okay, due to induction, wherever the south pole is being rubbed, at that place north pole is formed, and where the end north pole is formed, there south pole is being formed. In order to make it faster and more powerful, you can even place two more bar magnets below the steel bar such that wherever the south pole is kept, opposite pole is being created. Wherever the north pole is kept, south pole is being created. So this method of magnetization is called as a divided double touch method. So what is this called as, children? Divided double touch method. There is one more method for the double touch only, we have it. So this is one more method of double touch, that is divided double touch, and this is general. So in this again consider the steel bar only. On this steel bar, what you means, you have to keep two bar magnets such that one bar magnet north pole is upwards, the other bar magnet opposite poles must be placing each other. So two bar magnets must be placed one beside the other such that it is being separated by one more wooden block. So bar magnet 1, magnet 2, in between wooden block is being kept. But these two magnets are kept in such that one north pole is facing, the other must be south pole is facing. If not, they won't withstand there, they will just move on. So due to attraction only they will be kept in. So now the whole content, so this bar magnet along with the wooden strip as well as one more bar magnet. So this complete element, it should be rubbed in to and fro like this. To and fro, left, right, left, right, left, right, continuously it should be rubbed from to and fro direction. So when this process is continued for a while, what we observe that due to induction, wherever the south pole is been moving, the north pole is formed, and wherever the north pole is been taken, opposite pole, that is south pole, is being created. To make it more faster, okay, and more stronger, you can even keep two more bar magnets below this, such that the opposite poles will be kept. So north and north, here south pole is formed, south and south, here north pole is formed. So these are the different types of getting magnetized. Apart from that, there is one more method, children, that is called as your method of induction, induced method. So this method is called as your induced method. So what is induced method, children? In this case, you have to consider some material like steel or iron, whatever you consider. Consider a steel rod. On this steel rod, let us wind some copper wire as shown in the figure. This is a copper wire wounded around the steel wire. And now whenever a battery is connected, what happens? When the switch is on, the current starts flowing. The current starts flowing across the conductor. So positive terminal, the current will be flowing like this continuously in one particular direction. Okay. Okay. And wherever, and so very clearly the current is moving here upwards and here downwards. So that means the current is moving in the anti-clockwise direction. The current is moving in the anti-clockwise direction. The end where the current is getting inside, moving inside, there north pole is formed, and the way the current is coming out, at that position south pole is formed. Like this, the magnetism can be induced inside a steel rod while passing the current through this. Okay. So this process is called as your induced method. I hope that if you have a complete clarity regarding the different types of magnetism. So till far you understood how a substance can be get magnetized. So, but there are ways where the magnetic property can be removed, and this property is called as a demagnetization. So how this demagnetized process has been done? So consider, suppose if you are continuously dropping the bar magnet, throwing the bar magnet like here and there, you are simply, okay, then what happens? So this is the rough handling of a bar magnet. You can easily, the demagnetization process can be done. Okay, so you should be careful while handling a bar magnet. So not only due to the rough handling, children, there are many ways where the demagnetization process can be possible. Okay, so one more is that whenever a bar magnet is getting heated, because of the heating purpose, the magnetic moments, that is whatever the alignment is there inside the bar magnet, they will get distracted and different positions will be aligned, and as a result it loses its magnetic property. So heating effect will loses the magnetic property, so get demagnetized easily. Rough handling of the bar magnet also demagnetize the given bar magnet. Even the high frequency current, if you lot a heavy amount of current, if it is, so normal current means okay, it gets a heavy amount of current, high frequency current, if it is passed through that, then also it gets demagnetized. So children, self-induction method also. Due to the self-induction, suppose if the bar magnet is kept without using for a longer time, it's simply left unused, then also it gets demagnetized. Why? What is the reason behind this? The reason is that, you know, Earth is considered as a huge magnet. So it itself has a north pole as well as south pole. That is the reason why a freely suspended bar magnet always points towards the north and south direction whenever it is held freely, because of the attraction of the Earth's magnetic power. Okay, so because of this Earth's magnetic power, the unused magnet, due to the self-induction, randomly it loses its magnetic power. So these are the different process of demagnetization as well as your magnetization. Okay, children. So so now let us understand how this magnetic substances can be stored. So whenever would you like to store the magnetic substances, always remember that between the magnetic substances, try to keep some wooden piece, or if not, at least an iron piece between two bar magnets. To consider two bar magnets, and in between that you try to place a iron piece. So why like this? Whenever you are placing an iron piece between two bar magnets, because of the induction, wherever the north pole is there, iron piece is there. Iron is a easily magnetic substances. So because its retentivity is low, gets magnetized easily. So opposite pole is created in the iron, and again when opposite pole is created in the iron, the beside one whatever is there again gets magnetized. So like that, this can be retentive. Okay, the magnetic power of the given magnets can be stored by placing an iron piece in between the two bar magnets. Okay, children. So apart from that, let us also try to understand the types of magnets. Okay, there are actually three types of magnetic substances. There are diamagnetic substances, paramagnetic substances, as well as ferromagnetic substances. So what exactly makes the difference between these two means, okay, diamagnetic, paramagnetic and ferromagnetic substances. Okay. So now, what are diamagnetic substances? The substances, the magnetic substances which are repelled by a magnetic substance. I repeat, those substances which will get repelled when taken near a magnet, they are called as a diamagnetic substances. Okay. So examples for this are something like antimony, gold, water. So these are the things, okay, like bismuth, lead. So that these are the substances, whenever a bar magnet is taken near these substances, they move away from this magnets. That means they're repelled by the given bar magnets. Water also, if you take a bar magnet near the water will get the water molecules get separated from each other. Okay, they move away from each other. So those substances which will repel a given bar magnet, which will exhibit a property of repulsion whenever a bar magnet is taken near it, that is called as a diamagnetic substances. So few examples for this is antimony, bismuth, water, lead, gold. So these are the substances. And what are paramagnetic substances? The name itself indicates the paramagnetic substances means partially magnetic substances. They feebly get attracted. So attraction properties are there but very little. Okay. So partially, para means partially attracting nature. And few examples for this is, okay, so for the few examples for this is chromium, Aluminium, platinum. So these are the few examples that they very hardly they will get attracted towards the magnetic substances. So those substances which are partially attracted towards a given magnet, then those are called as a paramagnetic substances. And now the last, regarding the ferromagnetic substances. What are ferromagnetic substances? Those substances which show a high tendency towards a bar magnet, like a high magnetic power. Those substances which are strongly attracted by a bar magnet are called as a ferromagnetic substance. These are partially attracted, these are completely repelled, and these are strongly attracted when taken near a bar magnet. These are called as a ferromagnetic substances. And the ferromagnetic substances are these, as I already told you that iron can be easily get magnetized whenever a magnet is taken near it. Iron, cobalt, nickel, and few more are few examples of ferromagnetic substances. I think you gained a complete knowledge regarding the magnetism, children. So just go through and revise the notes completely, okay, and keep practicing, children. Until then, take care. Thank you.